let's look at this problem. For a given function involving both x and y, okay? And here the question is find the dy dx. So dy dx, you know that you are supposed, so if you're supposed to treat y as a function of x, okay? So whatever variable is on the top, you treat that as a function of whatever variable you have on the bottom. Treat that as a function of this other variable, okay? All right, so now you know what's going on, and let's go ahead, differentiate the equation. So differentiate the equation, I will have to do it both sides. Okay. Minus 4. All right. The right hand side is equal to 0 because the derivative of constant is equal to 0. Now the left hand side have d dx of y squared minus, I can pull out the 5 and d dx of y, okay, plus d dx of x squared. All right, so I'm writing out baby steps for you, so then you can practice the baby steps. I'm gonna start from the lesser term and go do it backwards, okay? So here we have a power function, x squared. Differentiate this by with respect to x. So the power rule tells us this is equal to 2x, okay? Plus. Now this, when I have a function of x, so I'm treating y as a function of x. When I have a function of x, I differentiate this function with respect to x. What is the notation for us to write the outcome of the derivative? It is as simple as this, right? So this function, this symbol, refers to the derivative function. We don't know what it is because we don't know what the y looks like in terms of x exactly. So we just keep it as is there. So write the 5, write the minus sign. Now we move on to the y squared part. So again, you treat the y as a function of x. And y squared now is a composite function with the outer function being the square function and y of x being the inner function, even though we don't know exactly what y is in terms of x. So now go ahead, apply the chain rule. The derivative of the outer function is 2y times the derivative of the inner function. So again, we don't know what a y is in terms of x, but we know that we can use the notation, we can denote that the outcome, the derivative, by this notation dy dx. So we have done the derivatives here for each term on the left-hand side. This equals 0 because the derivative of minus 4 is equal to 0. So what we want to do is to simplify this equation, and so then we can have a simple dy dx on the left-hand side. So here I see a dy dx here, and I see a dy dx here, so it's a common factor of these two terms, and when you factor it out, I have then 2y minus 5 times dy dx plus 2x equals 0. So I'm factoring out the dy dx. Next thing I want to do is to bring the 2x to to the other side. How do I do that? I do minus 2x and minus 2x, so this will cancel, and I am left with minus 2x, for example, right? And now I divide both the equation, both sides by 2y minus 5. So I have minus 2x over 2y minus 5. This is what the dy dx is.